morning, students. Today we are going to start air and atmosphere. This is your part 7th. In this lecture we'll talk about preparation of oxygen, as well as we'll talk about physical and chemical properties of oxygen. So let's get started. First, we'll talk about preparation of oxygen. Already we have discussed in previous lecture how oxygen can be prepared. The first example I am going to give you. You can see we can prepare oxygen from metal oxide. And what is a metal oxide? Whenever metal combined with oxygen form metal oxide, simple, and on heating metal oxide you will get metal along with the oxygen gas. It is very clear from the examples. You can see that here it is a metal oxide, mercuric oxide and silver oxide, and on heating they are giving mercury and silver along with oxygen gas. And oxygen gas you can get by heating metal oxide. So this is your first method, how you will get oxygen from metal oxides. Now next is that you can prepare oxygen by heating potassium nitrate and sodium nitrate. Already we have discussed what is nitrate and nitrite. Whenever NO3 is there, that is called nitrate, and whenever NO2 is there, that is called nitrite. So you can see here these examples are given. Whenever potassium nitrate, KNO3, it is very clear, and NaNO3, that is called sodium nitrate, and potassium is there. First one is that potassium nitrate, and second one is that sodium nitrate. And on heating you will get potassium nitrite. Here you can see that difference is that nitrate, in the case of nitrate NO3 is there, in the case of nitrite NO2 is there. And what will you get? You will get oxygen. So by this method you can get oxygen from potassium nitrate and sodium nitrate simply on heating. So this is the second method. We'll talk about third method, laboratory preparation. You can see what is a laboratory preparation. Already we have discussed, and it is very clear given in your book how you will get oxygen in laboratory. Oxygen is made in laboratory by passing manganese dioxide, by using manganese dioxide and 20% of hydrogen peroxide. What is the formula of hydrogen peroxide? H2O2. Yes, my dear students, you can see here H2O2, that is the formula of hydrogen peroxide. And what happened during the hydrogen peroxide? Hydrogen peroxide is added drop wise through the Thistle funnel, that is called Thistle funnel. You can see there is a Thistle funnel, and you can put the hydrogen peroxide drop by drop in round bottom flask, that is called round bottom flask. And in that round bottom flask it contains manganese dioxide, and that manganese dioxide it acts as a catalyst. Here I am written peroxide in the presence of catalyst manganese dioxide result in the formation of oxygen gas, and that oxygen gas formed passes through the delivery tube. Where is the delivery tube? You can see clear. Here is the delivery tube. These are delivery tube. And this delivery tube will get the bubble of oxygen. You can see that oxygen is here, and that oxygen is collected in this part. The upside down beaker is kept in water, and in this region you can collect oxygen. So this is a method you can get oxygen in laboratory. So laboratory method you use only hydrogen peroxide, In the presence of manganese dioxide, it is used as a catalyst. And why we are using hydrogen peroxide, already we have discussed in our previous lecture. Why we are using hydrogen peroxide? It does not require heating. Hydrogen peroxide is a safe chemical. It is not a dangerous. And evolution rate of oxygen is moderated and thus under control. That's why we are using hydrogen peroxide. Now, next one is that physical properties of oxygen. What are the physical properties of oxygen? You can see, first one is that it is colorless gas. Second one is that it is odorless and tasteless. It does not have any taste. Slightly heavier than air. Slightly soluble in water. And it is neutral gas. It is neither acidic nor basic. It is neutral gas. And you can see the symbol of oxygen here. It is given O. And what the atomic mass of oxygen is? 16. And atomic number is 8. Already we have discussed. Atomic number is 8 and mass is 16. So it is very clear what is oxygen and what the physical properties of oxygen. Please note down in your copy, my dear students. Under high pressure and low temperature, it can be liquefied into the bluish liquid. Means oxygen can be liquefied by applying pressure at low temperature, and you will get blue liquid of oxygen. Now, next topics are chemical properties of oxygen and respiration and oxidation. Let's start. We'll talk about what is combustibility. The combustibility, the oxygen is good supporter of combustion, although it itself is not combustible. Means it will support in burning, but it will not get burned itself. That's why extra oxygen gas cylinders are being used by the builder. Which builder? Gas builder. Because oxygen gas support in burning, and also it help in the increase the calorific value, means temperature, heating temperature. Calorific value means energy, you can say that. Next one is that oxidation. Oxidation is the reaction in which an element combined with oxygen. What is the oxidation? Whenever any element combined with oxygen, that is called oxidation. Only for your class. The reaction between oxygen and magnesium metal to form manganese oxide. Whenever these are examples is given, what is the formula of magnesium? Mg, and Mg react with O2, what form? MgO, and it will give dazzling light. I'll show you in classroom how magnesium will get burned. And that magnesium is used in fulgari and many crackers things, because it create dazzling light. That's why magnesium is used. So these are the examples of chemical reaction. What is oxidation? Again I am going to ask. Whenever metal react with oxygen from metal oxide, and that is called oxidation. Next one is that type of oxidation. You can see here it is very clear. Fast oxidation. What is fast oxidation? This is oxidation that occur rapidly. Meaning that the reaction is immediate. That is called fast oxidation. You can see example. Combustion. Combustion is example of fast oxidation. You can see very clear in image. Refer to the process where substances burn in presence of oxygen, giving out heat, light in this process. You can see coal is given, coal, you can say the wood is given, and whenever wood is get burned in the presence of oxygen, what it will give? It will give carbon dioxide, water molecule, and here you can see delta H. Delta H is the form of heat and energy. It is a symbol of energy, internal energy. So whenever any combustible substances burn in the presence of, that is a symbol of CXHY, means it is a variable, react with oxygen. What is formed? Carbon dioxide, water molecule, and energy in the form of heat and light, and this is the example of combustion. So please be clear, my dear student, what is a combustion and what is a fast oxidation. The combustion is the example of fast oxidation. Next, slow oxidation. What is the slow oxidation? As its name indicate, it is the slower version of the oxidation. Yes, my dear student, it is very clear. It is a slower version where products are slowly ruined over the time. Example, products become spoiled and discolored, metal corrosion, rusty, car door, and food turning moldy, means retaining of food and rusting. And suppose you keep the pickles for the many times, it get spoiled, it start giving the foul smell. It is also example of oxidation, but it is a slow oxidation because it take time. Examples are given here. You can see first one is the respiration. Respiration is also example of slow oxidation. In your body, food, after the digestion of food, your body has what exactly things which are used by cell, that is called glucose. And you can see glucose react with oxygen, and during respiration you are taking oxygen inside your body and releasing out. And what you are releasing out? You are releasing out, you can see, carbon dioxide, water vapor, and energy. Your body get energy for doing different work, and that energy you will get in the form of ATP, adenosine triphosphate, and ADP, adenosine diphosphate. The respiration is an example of slow oxidation because your food get oxidized, means glucose react with oxygen, and already we have discussed whenever anything combined with oxygen, that is called oxidation. So respiration is an example of slow oxidation. So my dear students, it is very clear what is oxidation, what is fast oxidation, what is a slow oxidation. Another example is rusting of iron. What is the rusting of iron? The red and orange coating that form on the surface of iron when exposed to air and moisture, that is called rust, and phenomenon is called rusting. Means when you expose the iron in open air and moisture, it will react with oxygen and form reddish layer over it. You can see very clear in the image here. Metal react with oxygen. You can see metal react with oxygen in the presence of water moisture. What form? Browny layer over the metal surface, and that is called rust. And what is the formula of rust? You can see very clear. 4Fe react with oxygen in the presence of water molecule. What is forming? Fe2O3 XH2O. Means XH2O means water molecule is variable. It can be vary. It may be 2, it may be 3, it may be 5. So that is the example of rusting of iron. So whenever I'll ask in your examination what is a rusting, you must write definition along with the equation. Please, my dear students, keep it in your mind. It is very important. Whenever you are giving any answer, you must write example also. Now, next example is that difference between combustion and respiration. First one is that rate. Combustion is a fast process. Yes, this is the example of fast process. And respiration is a slow process. Means first one is the fast oxidation and second one is the slow oxidation. Temperature. It occur at high temperature. Combustion always require heat and it occur at body temperature because respiration always occur inside the body. Place. It can occur anywhere. Combustion can occur anywhere. But cellular respiration means respiration always happen inside the body. And energy is released a single step. Energy is released in a single step in the form of heat and light. But in the case of respiration, energy is released in step and stored in a chemical molecules that is called ATP. And already I made you understand what do you mean by ATP, adenosine triphosphate. We will talk about in these things in biology section. So what is the difference between combustion and respiration? Please learn and make down in your copy. It is very important for exam. It may be for your further class. So today for this class, please note down all the important topics. Good day and have a nice day, my dear students.